Hello, Algebra 1 students, and welcome to Topic 6, Exponents and Exponential Functions. We are going to skip Lesson 6.1 and go straight into Lesson 6.2 on exponential functions. Before that, though, I do want to review exponents with you. So the idea of exponents here, I'm going to draw, where do I want to put it? Right here, maybe. So a to the m. Okay, so this is a big A. We call that A the base. Okay, and then this m right here, we're going to call that the exponent. Again, I'm going to abbreviate exponent. You can also call that the power. Okay, and really what A to the mth power means, or A to the mth, is A times A times A dot dot dot. And you write that A m times. So it's A multiplied m times. That's what it means. Okay? Now, when it comes to certain exponents, so if you see like A to the second power, we call that squared. Squared. If you see A to the third power, we call that A cubed. And if you see A to the fourth power and beyond, we just say to the fourth power. So that's just the fourth power. A to the fourth power. Okay. So a little bit of a reintroduction to what exponents are, some notation things, and now I need to talk about two rules that are going to be important today when we talk about exponential functions. So new rules. Rule number 1 is the zero exponent rule. If you have any base raised to the zero power, it's always going to be 1. Doesn't matter what that base is, it's 1. Okay. The other rule is the negative exponent rule. If I have a to the negative nth power, what this is going to do is it's going to reciprocate your base. So a becomes 1 over a, and then the exponent on the a turns positive. 1 over a to the positive mth power. So again, I like to call this the reciprocal rule. Right? So you have the zero exponent rule and the negative exponent rule, which is the reciprocal rule. These two rules need to be remembered when we talk about evaluating exponential functions. Okay? All right, so that's your quick review on exponents. Let's jump right into what exponential functions are. So on example 1, what are the key features of f of x equals 2 to the x power? So notice here, right, this is an exponential function. Notice where your x is. Your x is the exponent. That is why these are called exponential functions. Again, your 2 is the base. So recall your function notation f of x. This could also be written as y equals 2 to the x, right? So again, understand that f of x is just your y. All right, so this is the first time you're going to see an exponential function. So let's go ahead and make a table of values to then plot and connect. All right. So when we make a table of values, I like to start with the x values of -2, -1, 0, 1, and 2. So I'm going to make this big table because a couple of the columns. So I'll go from -2 to -1 to 0 to 1 to 2. So these are the x values I'm going to plug in. So this middle column is going to be where I plug it in. So the f of x equals 2 to the x. So I'm going to take my x values and replace it for this x. Okay? So let's do that now, right? So let's go 2 to the negative second power. Again, taking this -2, putting it in place of x. This is the negative exponent rule, which means you reciprocate that 2 to make it a 1 over 2, and then the exponent turns positive. And 1 over 2 squared, 2 squared is 4, that's 1 over 4. So then, and I'll continue on in a second, but then my last column is going to be my ordered pair columns, right? X comma y. Remember that y is just the f of x, so what we just got here, right? So x comma y, but your y is f of x. So this ordered pair would be -2 and then 1/4. All right, let's continue on. So middle column, let's replace your x with -1. So 2 to the negative first power is 1 over 2 to the first, but 2 to the first is just 2. So that's 1/2. So our next point would be -1 1/2. All right, then we're going to plug in 0. Here's your 0 exponent rule. Anything to the 0 power is 1. So we plugged in 0 for our x, and we got out 1 for our y. Now we're going to plug in 1 for the exponent, but 2 to the first is just 2, so that's the point 1, 2. And we're going to plug in 2 for our exponent, and 2 to the second is 4, so there's your point 2, 4. So here are our 5 ordered pairs. Now let's remember before you graph that when you plugged in 0 for x, this right here is going to be our y-intercept, right? So when x is 0, the value you get is the y-intercept. So let's graph these. So -2 1/4 would be right around here. That 1/4 is kind of tough to graph. It's really close to the x-axis. -1 1/2 is halfway up this box. 0 1 is here. 1 2 is here. And 2 4 2 4 is here. And because I have prior knowledge of these things, I know what the shape looks like, right? So if I connect these dots to the right, it's going to go up, 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 up. And that's not quite good, but it's close enough. Up, 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 up. And to the left, it's going to go towards this x-axis, but it's never going to touch it, but it's going to keep creeping closer and closer and closer, almost like it's parallel, because it's hard to draw, but it's actually creeping closer and closer and closer as you go to the left here. And that's what this graph looks like. I like to call it like a banana graph, but this is what your exponential functions look like. Okay? The one thing to point out in this problem here is as x is going to the left, and to the left would be called negative infinity, right? Left. As x goes to the left, your function, your y values, are getting closer and closer to the x-axis, where the y value is 0, right? And 0 is the x-axis. So that's your left-hand behavior. Okay? Over here on the right side, as x is going to positive infinity, which is to the right, sorry. 1 second. As x is going to the right, your y's are also going up and up and up without bounds. And that means your y's are also approaching infinity up here. And that would be going up. So these two sayings right here, we call these the end behavior. You'll do more of that in Algebra 2, right? But typically on one end, it's going towards the x-axis. And on the other end, it's either going up, 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 or down, 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 down. Now, let me show you that Desmos can do this for you, right? So let's clear this. Let me escape out of here. Here's my Desmos tab, right? So I already zoomed out 1, so I'm counting by ones. So I'll just type in here, f of x equals 2. You can use the caret button, which is Shift-6, or if you grab the keyboard, you would just use the A to the B button, and you put an X up there. And notice there's your graph. And again, just as it looks here, right? On the left-hand side, it's going closer and closer to the x-axis. Again, it almost looks like it's on top of the x-axis. That's just the limitations of Desmos and its graphing ability. And on the right side, you're going way up, 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 up. Okay, so again, let's just talk about the characteristics again, just to emphasize, right? Because when you talk about new functions, you should know. So again, let me graph that. It's the same graph. So, you know, -2 1/4, -1 1/2, 0 1 1 2 2 4, right? Has this shape like that. Has that shape like that, right? So again, let's talk about domain and range, right? So for this graph, your domain, your x's, notice that your x's here go all the way to the far left. I see this arrow. And your x's here, now it's going more up than it is to the right, but the arrow means it's going to the right. Your x's can be anything. All real numbers. Now, the range, on the other hand, is different. Let me use a different color. Let me use blue. So for the range, notice that nothing is down here. right? So your y's in this case will not be any negative numbers. Also, because the graph never touches the x-axis, right, where y equals 0, your y's cannot be 0. But it can be anything bigger than 0 because everything's going up. So this range is y is greater than 0. Down here, they use a word that I didn't know they were going to use, but it's here. So it's called an asymptote, right? When the function gets closer and closer to the x-axis but never reaches it, this dotted line I just drew is called an asymptote. You'll do a lot more of that with Algebra 2. Last but not least, increasing and decreasing. So when we talk about increasing and decreasing, as we go from left to right, what is happening to this graph? Is it going up or down? So if I start here on the far left at this arrow and I go to the right, we're increasing slowly, 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 and then we really turn up. So this is always increasing, this graph. All real numbers over all of the x values is this graph increasing from left to right. And it's never decreasing. So there is no intervals where it's decreasing. Okay, so that's, again, you'll see increasing and decreasing maybe in the state test. So there you go. Okay, so there's some key features of the exponential graphs. And again, you can just use Desmos and look at the picture. So now let's get general. So here we go. This is our general introduction to what an exponential function is. So keep this in mind here. This is one of those slides you should study when you're studying for your test. So an exponential function is the product of an initial amount and a constant ratio. So notice here, this is your formula. F of x equals a times b to the x. Sometimes I see it like this. F of x equals a, and then the b is in parentheses to the x. So you might see it either way. But whatever way you slice it, the a, the number in front, is called the initial amount. Okay? This is going to be your y-intercept, your starting point. So again, if you think of a word problem, that's your starting point. Everything goes off to the right because word problems are positive, right? And then this b is going to be called this constant ratio. It is the number by which you're increasing by. And when you talk about exponential functions, it's multiplication and division, not addition. That's why you have this times symbol here. It's multiplication. All right, so keep that in mind. Okay? So there we go. So this is the formula you have to use. It's very much like how I had you memorize slope-intercept form. This is your exponential function form. Y equals ab to the x.